Okay, so this was question 8. I did this one in class as well, but we'll go through it again here. So you had to find the volume of foam protectors that protect the goalposts in a rugby game. So I've just done a bit of pre-work, as you might have noticed here. So the volume of a cuboid I've written down is length by width by height, and the volume of a cylinder is pi r squared h. So the cuboid is length by width by height. Now, just to point out that this question is looking for your answer in meters cubed. All right. So it's given me the height in 1.8, or the length, basically the big part here. That's 1.8 meters. So I'm going to have to convert these guys to meters as well. So this is going to be 0.3, this will be 0.3, and this will be 0.15. All right. So let's do that. So to find the volume of the cuboid, you multiply the length by the width by the height. So it's 0.3 multiplied by 0.3 multiplied by 1.8. And that answer is 0.162 meters cubed. All right. And the cylinder is going to be pi r squared h, but the value that they've given us here is the diameter. So I need to divide this by 2, which is 75 millimeters. In meters cubed, that would be 0.075. All right. So you're going to have pi, which is just going to stay as pi for the moment, multiplied by 0.075, multiplied by 0.075, multiplied by the height, which is 1.8. And when you put that in, you get 0.0318 meters cubed. So the volume of the foam inside the protector is going to be 0.162 minus 0.0318, which is equal to 0.1302, but it wants it to 2 decimal places. So my final answer is 0.13 meters cubed, and that's my answer there. All right. You may have guessed I have the answers to this already done out on a calculator. That's why I was able to come up with them so quick in my head. All right. Part B. Okay, so I made a complete mess of this the first time I tried it, so I'm going to go again. So I had to really think about this for a second. So if you have your protector that has a cylinder shape going through it, okay, so if I just maybe try to... Okay, so the entire inside part of that cylinder is going to be covered in PVC, but not this area here or the circle down here. So that's why it's the curved surface area of the cylinder we need, and the total surface area of the cuboid is needed, but we need to take away those two. So we have to take away 2 pi r squared here as well. Okay, so this is going to take a minute, right? So I'm going to cut to the chase here, lads, because otherwise I'd be doing this question all day. So the total surface area of the cuboid I've worked out already, which is 0.162 meters. No, I'm reading the wrong one. Lads, I'm all flustered now. 2.34 meters squared. So that's the cuboid. But we have to cut out this hole, and we have to cut out this hole. All right. So I'm going to take away 2 pi r squared. Now, if I do that on a calculator, all right, so it's 2 pi by the radius multiplied by the radius again, which gives me 2.34 minus 0.0353. All right, you do that and you get, so it's 2.34 take away 0.0353, which is 2.3047 meters squared. So that's the cuboid sorted. We need the curved surface area of the cylinder. That's 2 multiplied by pi multiplied by 0.075 multiplied by 1.8. So if I do that on the calculator, we get 2 multiplied by pi multiplied by 0.075 multiplied by 1.8, which is equal to 0.8482. All right, so then the protector is just going to be this guy and take away this guy. So you get 2.3047 minus 0.8482. And that is going to equal, just give me a sec to do this in the calculator. So we get 2.3047 minus 0.8482, which gives me 1.4565 meters squared. It wants it to two decimal places, so that's 1.46 meters squared. And that is the area and volume question.